I won't be talk too long anyway. So, a way of dealing with these is to use substitution, which you might think makes it more complicated, but just bear with me, give it a go. So, what's our rule for difference of perfect squares, or difference of two squares? What would this a squared minus b squared, what does that factorise into?
A squared minus b squared.
Huh?
A squared minus b squared.
No, that's the expanded form. What does it factorise into?
A plus b times a minus b.
A plus b bracket a minus b, yeah? So that's the rule you're using at all times. If you happen to see two terms that are squared and there's a difference between them, you can use the factorised form on the far right side, a plus b bracket a minus b. Alright? That is always what you do in this situation if you are asked to factorise something like this. Make sense? Yeah? Good? Alright? So when I say I'm going to use substitution, I'm going to pretend that the x minus 2 is equal to a and b is equal to x plus 3. Alright? And the reason I do that is because now my equation simplifies to become a squared minus b squared, which, what do you know, is exactly what we started with on the right hand side as our rule. Alright? We know that this factorises into a plus b, a minus b. Right? That's just the rule, we haven't done anything fancy there. Then I just have to plug in the substitution. So a is x minus 2, b is x plus 3. That's just the first bracket. Second bracket is a again. Alright? But then this negative sign is where a lot of people got tripped up. So it says I have to subtract b. I have to subtract all of b. So take away all of b. Alright, so let's simplify this first. What is x plus x? 2x. Minus 2 plus 3 plus 1. Alright, second bracket. Now I'm not going to simplify yet because there are some brackets there. So if I remove the brackets, what happens to the x? It becomes a negative. What happens to the 3?
Becomes a negative.
It also becomes a negative. Alright? So if I simplify, this one can't be simplified any further. This bracket now can. What's x take x?
0.
0. What's minus 2 minus 3?
Minus 5.
Minus 5. That's it. That's as far as we can go. The book might write like this, but it doesn't really make a difference. Alright? Now, to reverse a little bit, back to this step here. When I say that you need to subtract all of b, if you chose to write this without the brackets, alright? Oh, sorry. So it's just x plus 3, which was what b was, x plus 3. Take away b. Alright? Think to yourself, what are you actually subtracting here out of this? Only the x, aren't you? You're still adding the 3. You've got to remember that you have to, according to this, you have to subtract it. Alright, so you've got to ask yourself, am I subtracting all of b, or just part of it? If I'm only subtracting part of it, like this here, where the 3 is untouched by the negative sign, you need to reassess your answer. Alright? Do you want to try another example?
I did it very differently, but I still got the right.
So, did you expand it out and then factorise back down?
Yes.
Yeah. Can you see how much my way is much shorter?
Sort of. I feel like this is
Expe-
easier for my brain.
Yeah. Expanding out, so I saw a number of people around the room would do it, and they did it fine. Expand this out to x squared minus 4x plus 4. Expand this out to x squared plus 6x plus 9. Gather all your like terms, then factorise the result.
Yes.
You will end up with the exact same answer.
Yeah.
This way is much faster.
Can you do that with all, like if there's two brackets that, with the power of 2, you can just always go x minus 2, x plus 3?
So whatever this is that. Whatever this is that.
Yeah, but you know how you get rid of the square? You know how the brackets are square?
This,
No.
this.
Yeah, they're squared.
Yeah, there's
X plus
that's
3
here.
squared. Yeah, so how do you just go straight to the x minus 2, x plus 3? And so
Because we remember that the way to factorise this, we know that that always factorises into this.
yeah.
That's the rule, right? The way Haley's done it is the long way. This is a shortcut that mathematicians over hundreds of years have decided, I don't actually have to expand everything out and factorise from scratch. I've noticed that every time I factorise this, it looks like that. That's a shortcut, right? You don't have to go through their steps if you don't choose to. However, if you don't feel confident doing this, by all means, keep expanding out and factorising back down the result, because you will get the right answer. This will save you scads of time in the future.
So do you definitely recommend doing that one?
I recommend practicing it.
Okay. It's like I don't feel confident doing that, but I feel
That's
really
fine.
confident.
Will, did you have a question?
Well, yeah, it was on something that I'd done here, so
I'll come over in a
I'll
second.
wait until you're done.
Right, we're going to try this one, and I want you to try it using the shortcut. And I talk to Will. I want you to try it. We'll come back.
It's the same question.
Exactly the same one. What do you need to do?
Yeah, I tried,
Mm-hmm.
I,
No, it's not
but it's
I'll
not
show
in
you.
the right
I'll show you.
format.
Not in the right format. That's better.
Okay.
It's not in the same format.
Okay.
It's 100% right. Remember how yesterday we talked about factorising completely?
Yeah.
You haven't done the complete.
Yeah, okay.
Yeah? Right. You need a bit more time to give it a go? Take that as a yes.
Yeah.
Yes.
I'm just wondering what's happening. It says, so,
Yeah.
my class, I just do add action, events,
Yeah.
so, and then type new, and then easy. This isn't easy to choose my classes, how do
So you change it from standard to decimal.
Okay.
So that's, remember that and write it down somewhere, because
Yeah.
if you can just switch between the two really easily. You don't have to make any greater.
Yeah, because it's also,
Yeah. Alright, I'll write in the first line and you can tell me if that's what you've got. So A is 2x minus 1, B is 3x plus 6. So my two sets of brackets look like this. 2x minus 1, take away all of B, which is 3x plus 6. Then 2x minus 1 plus all of B, which is 3x plus 6. Make sense? No? Yeah? Good? Still not sold on it?
Still not really getting it.
So when I remove this bracket here, what's going to happen to the 3x?
Maybe.
Becomes negative. What's going to happen to the 6?
Negative.
Also negative. 2x minus 1 minus 3x minus 6, and 2x minus 1 plus 3x plus 6. So let's gather our like terms. I've got 2x's here and minus 3x's there.
Negative.
Negative x. Minus 1 minus 6 is minus 7. 2x's and 3x's.
5x.
5x's, 1 minus 1 and positive 6. plus 5. Right. This is where most people, or a lot of people got to, went to the answer and didn't see that. So what can we do for one step further?
Take out the common factor and the second set of
This one?
Yeah.
What's the common factor between these two terms?
5.
5. So we'll just write a 5 at the front. We'll move that bracket to the front. Minus x minus 7.
Take out a minus.
People went happy and decided to check the answer, and it's still not right. So what do we do, Hayley?
Take out a minus.
Divide both of these by a minus. So the common factor right at the front is minus 5 now. Whoops, it's plus. And in the brackets is x plus 7.
It was supposed to be 5 times x plus 1.
Yes, good work. Thank you. Slight mistake there. Dividing them both by 5. Yep. Alright, so this step here. When you reach that step, you're not wrong, you're just not finished. Alright? So your overriding question at every step is there a factor I could take out? Alright? So when you get to this step here, you've got to ask yourself, are there any other factors? Yes, there's another one. Ask yourself, are there any other factors? Yes, there's one more. Alright? Does that make sense? I wrote divide because that's how you remove a common factor. Alright? If you see questions like this written on methods exams and things, they will always phrase it like this. Factorise. They don't just say factorise.